Hi and welcome to the new series How to Bot. If you're interested in developing image Python bots for video games, then you came to the right place. I will go into the details on how to step-by-step make a bot for a game. By the end of this series you will be capable of developing your own bot for any video game you like. Our first project here is to develop a bot for old-school RuneScape private server called RuneWild. The goal is to make the bot capable of fighting Nex start to end, and later on we will improve it further to handle situations like death, banking and out of resources, etc. This is episode 1 of the Nex Auto-Fighter bot. Let's do it. This tutorial assumes you have the following: Python 3.8 or higher version. This is the programming language we're going to use, and we need the Python interpreter to be installed. To write programs you will need a code editor. As far as Python is concerned, you can use Notepad to do this. But in order to make the process easier, most people prefer to use a code editor. You can use whatever you like as long as you know what you're doing. For me, I use Visual Studio Code with Pylint and Vim extensions. Lastly, you need to install CVBot. Once you've Python installed, you can do this simply by running pip install CVBot. Logically, we should start by making it path to boss room, but we will leave that to the improvements part. We will assume that the player has already made it to the boss room, so we will handle the boss fighting first. I have included a link in the description for anyone who wants to know more about Nex Fighting. In order to avoid unnecessary and maybe fatal damage, we need to avoid the lines or paths that lead to the center. We want to position ourselves in one of the 4 corners of the room while still being in attack range. So step 1 here is to know the current player position in the room in order to path to where we need to go. This will help in the future for doing things other than moving to corner, like fighting mini-boss in the corners, exiting the room, or using prayer stand. We're going to use the minimap in the top right corner to determine player position. The idea here is to create a full map of the boss room, then use image search to find our current minimap in the full map. I'm going to be using my own image automation easy-to-use Python package. Every function used in this tutorial will have a detailed documentation. Link is in the description. We will start by creating minimap.py file for our script, and create a folder to collect minimap images in. We will call it images. First things first, we will start by making a script that takes images of the minimap while we move around the whole boss room. We're using Visual Studio Code with Pylint installed to help fix syntax errors without having to run every time to check. First things, import modules and functions we want to use. We're using Windows module to reposition the game window to the top left corner and/or X0 and Y0. And import 2 more functions, get region and save image, in order to take a screenshot and save it to our images folder. We want to take a screenshot of this region. We can print screen and take exact measurements of the region. I will be using paint.net because it's simple, easy to use and suited with the right features we need for image-based bots. Coordinates we want are x 573, y 40, width 161, height 150. These coordinates are based on the game window being on the top left corner, so make sure the game window is in that position before starting the image taking process. In code we will have an indexing variable I, and we will make an infinite loop so that recording will only stop manually. getRegion function is used to take image of a screen region. We're going to use the minimap region we've extracted earlier. We will use Save Image function to save every image using the current index. We can check the resulting image before collecting Minimap images. As we can see, the image is perfect. Let's test the whole thing. It's a bit too fast, 500 images in a very short time. I will use a delay to slow down the recording process. About 250 milliseconds should be good. Before starting, make sure the minimap is reset and positioned to north when you're collecting minimap images. We need the angle to be consistent when compiling all the images into one full map. Now let's go to Nex room and start collecting minimap images. Make sure you cover the whole boss room by moving on the middle parts, the far left, right, top and bottom parts. The more collected images, the better. Also, there is no need to repeat parts you came across. Once this process is done, we expect to have around 1,000 plus images. We will move on to make a script that process all these images into one full minimap image that we're going to use to find our current location. To do this, we need two functions, one to process the image. That means cropping it to the area we need and remove noise like the red flag that can appear when player is moving. The second function we will use to compare each image to the previous image and determine based on that comparison where the new minimap image is located inside the previous image. We will start by developing the processing function. As we said, this will remove noise from the minimap images and give us a clean image we can use later. What type of noise do we have? To answer this question, we need to look into what information in the images we've collected are unnecessary and therefore needs to be removed. For example, we can see that the red flag is unnecessary and must be removed. Also, the white parts on the edges only complicates the map and serves no purpose, along with NPCs' yellow dots and players' white dots. What we have to do here is to study the color ranges and measure the exact range we're looking to remove. For the red flag, we can see that the red value should be high and the blue is low. If we do a search for colors that match this criteria and change its color to gray to match the minimap main color, it should remove the red flag entirely. We will define process function. This is the first function I was talking about earlier. We're going to use it to clean the minimap image. As you might have noticed, our minimap images include some bits of the game interface around it. So the first step is to crop the image to the minimap part only. Let's check the results. Looks great. Next, we want to clean this cropped image from unnecessary information like the red flag, dots, and reduce color in the minimap. This process is called noise reduction. It will improve our position detection algorithm. We're using NumPy because it has great matrix manipulation functions, and as it turns out, images we're using are already represented as NumPy matrices. We're going to use logical and function to remove the red flag by specifying that channel 2, which is the red channel, has value larger than 80, meaning strong red, and channel 0, which is the blue channel, has value lower than 150, meaning not so strong blue. This will give us a mask for the red flag, and we're then going to use this mask to turn the red flag to gray. We're going to do the same for other smaller parts of the minimap. Finally, we will turn any value higher than 200 to be 200. This will turn parts with strong color like yellow and white to gray. In the end, we expect the minimap image to be mostly gray and black. Now we will move to merging all our images together into a full map. The idea here is to read the images in order. We will exploit the fact that the images are already chronically ordered since we were moving as we were recording. Each image will either be similar to the previous image or slightly offsetted. We will compare each image to the one following it to tell the exact offset and then paste that image in the correct coordinates. We will be doing this image by image until we end up with all images pasted into our full map image. We will first start by importing process function we just made to remove noise from the minimap images, followed by CVBot.io read image to read our saved on-disk minimap images. We will call the merging function compile. First, we want to read the first image. I chose number 200. Because I started the recording earlier and the first 200 images included parts outside the boss room. We will load the image into the variable fmap. This will be our canvas for pasting images into and forming the full map in the end. I changed fmap class variable name to full map because it will let me know which image is shown when I display the images, since we will be dealing with multiple images. Anyhow, we will go ahead and process our fmap image, and this is done using our processing function. We need a variable, we will call it lpos. This will keep track of the position of the last image position we pasted into the canvas fmap. And since this is the first one we have just loaded from disk, this means the current position is 00. Before I forget, it will be interesting to time this and see how long it will take to compute everything and create a full map. I'm going to import time and take a timestamp st, which is the start of the computation, or the major part of it at least. It mostly consists of a bunch of for loops. The first one here will go through all the minimap images from 200 to 2630. I want to read two images I and I+1, we will call them image A and image B, and of course we should process them after reading them. Comments are always good, you won't regret taking the time to make them. Next, we need to import image from CVBot images. Oh, I forgot numpy as well. This is because we want to create a black images, which is what numpy zeros is doing here. The black image we just defined is of width 108 and height 96. This is 4 pixels more in width and height compared to our processed minimap image. You ask why is this, and what are we going to use it for? We're going to paste the images we just loaded into this black image. The first one, image A, will be centered in the middle of the black image. To do this, we'll use the class function drawImage with offset 2. Because we are drawing our minimap image into the black image, which has 4 more pixels in width and height, and as you can imagine, there will be 2 black rows above and below, and 2 black columns to the left and right of the image DT image. The idea here is to compare the two images, image A and image B. We will have the variable best to keep track of the best matching position between the two images. If you look into any 2 minimap images in a row, you will notice that the maximum displacement between 2 images is 2 pixels in the X and Y direction. Just to be sure, I'm going to use 4 pixels instead of 2, in case of outliers. We are going to use 2 for loop, J for the X coordinate, and K for the Y coordinate, to go through all the possible positions. BT image will be the second image, which is image B pasted into different positions from top left corner to the bottom right corner of the black image T image based on J and K. We will then make sure the 2 first and last rows and columns are black to match AT image by turning the value of each row and column to 0. This must be done to avoid the false positives. Let's just call this image here BT. The result res will be the result of the mean squared error between the two images AT image and BT image, which is just pixel by pixel comparison. The lower the value, the better the match. This code feel a bit dry. I will add some comments. While we're doing this, let's take a look at AT image to show you what I'm talking about. This is not what I expected. Oh, it's because I'm running minimap.py, not our current module. Let's fix that. See, there are two extra black rows and columns on each side of the minimap image. Let's finish the comments. Looks like I forgot to import MSE. Now, to make sure we have the best match, we will keep comparing our current MSE result with the best score we have so far. If the difference or matching score is lower than the current best, we just found a better matching position, and we want to save that as current best. J and K are subtracted by 2, because as we recall, the image is positioned at x2, y2, inside the black image. Once we have the matching position, we want to add that to our current offset LPOS to get LX and LY, which are the positions we're going to use to draw image B into our canvas. Now, we want to update LPOS to reflect position of image B inside the canvas. We want it to be 0 if LX or LY is less than 0, because there are no negative positions in images. The lowest is 0. We will go ahead and draw image B into the canvas. And get a second timestamp ET for the end of the process. Print the time and round it so it doesn't show a long float number. Then show the full map image. We will also want to save the full map image, but first we need to import save image from CVBot. Let's save as full. Just fmap is good. Quickly comment and review the last bits. I just can't help myself sometimes, but make sure the comments explain the code well. Everything looks good. Let's run. Fingers crossed. Actually, this might take a long time. Let's see the process by showing the full map for each step, just to make sure it's doing the right thing. That's weird. This does not look right. Let me check. Let's see the end result. Yeah, that is not right. Okay, just found it. It's this black padding part. The -2 should be before the colon because it should make columns from -2 to the end 0 or black. It was making all the columns from the first to the second from last column 0 or black, and that was causing the weird result. Let's check now by showing the canvas on each step. There we go, hallelujah. Looks exactly how we want it. Let's see the end result in the image viewer. Perfect. Before making the position detection function and celebrating, we need to improve the full map for better detection. First, I will start by removing these black spots, which are the result of NPC location on the map. Looks great. We also need to add more black rows and columns to make detecting positions at corners possible. I will add around 30 rows and columns at the top, bottom, and right. Left is not necessary because we already have the pre-boss room there, and that's enough. Once that's done, it's finally time to see the results of our work and head straight to making the final position detection function. First, we need to import getRegin function to take a screenshot of the game. Also process that Minimap screenshot image. We also need to read the full map image as a global variable. The function we're going to use to find the current location is called lookFor. This will do image search to find the processed Minimap screenshot inside the full map and give us the position. If it's not found, it will return none. Let's go ahead and test this on one of the Minimap images we have on disk. First, I will override the getRegin function instead of taking a screenshot. It will just return the image we just loaded from disk and print the position. Nice, it just returned a position. That means our detection works. But before celebrating, we want to see that position in the full map and compare it to the Minimap image and make sure it's actually giving us the correct position. I'm going to simply show both images. Since position might be none, we will have to add an if statement. I will also add a red cross to pinpoint the detected location on the full map. Let's run. Okay, this should be .image instead. Let's see now. Okay, looks good. We want to compare this to the original image. It's not cropped, but it's still processed because the player dot isn't there. Let's show the image before being processed. Wow, looks really good. This is actually working. Let's see more images. From 230 to 800 should be good. This is going to take a long time. Let's just go straight to 530. It returned none this time, most likely because lookFor function is set to 0.8 threshold. Let's lower that to 0.6 to have less strict search. Great, it's working again. Let's test other images, 730. Looks good, but I feel like it's a little bit off the true position. How about we try to add an offset to fix that? Let's start by -1 for X and 9 for Y. Add some comments so I can tell which part of the code is for testing. It's better, but not quite there. I will keep changing the offset until it's accurate. For the final and sweet part of this episode, we will test this in-game. First, make sure the window is positioned on X0, Y0. Then run getPos function in an infinite loop until we manually exit the program. Let's also add a continuous view on the full map with the current location cross. We will be using OpenCV package because it supports variable input time, which allows for the viewing to update itself without requiring user input. And add some more comments for anyone who will stumble into this. Okay, everything looks good. Let's go to Nex. Last review. Let's also remove the Minimap screenshot view because we won't need it anymore since it's already displayed in-game. Time for the real test. Oops, we forgot to add 255 to the end of our array. As I mentioned earlier in the video, we need to do this when the image is a screenshot. Quickly fix it here. Looks like I forgot the one in the process function. Okay, now let's try again. Great, no error. Let's enter the room for it to start displaying position, and immediately an error as we enter. Let's fix this quickly. I think I added a 255 where I shouldn't. The full map image is loaded from disk, so no need for an extra 255. Now let's try again. Here we go, let's move. Oh damn, let's fix this quickly. The full map image is getting drawn on over and over. Let's just make a copy before drawing to prevent this. Hope we don't die while doing this. This is really hard, but I think I got it. Let's run now. Oh wow, looks phenomenal. This is beautiful. I feel like it's off by a bit on the Y coordinate. Let's try to fix that while we're here. I will tweak the offset a bit, until the detection is accurate. Okay, I think I'm happy with this result. I believe it's accurate and doesn't throw errors. Now we have our position detection script done. I will wrap this video here. In the next video I will be working on reading stats like Nex HP, RHP and prayer, as this is really vital to be able to fight Nex without dying. Nex HP is important because later on we will add the ability to fight Nex NPCs or minions. It's also important at this stage because we need to detect Nex death faster. Alright, that's it. Thanks for watching and consider subscribing to be notified when the next episode drops. Take care.